Okay guys, so for our first problem, so as shown here ay isang simply supported beam. So at point A, you have a pin support and at point D, you have a roller. So for number one, we need to derive the expression for the shear force and the bending moment for each segment of the beam. So ito guys, yung sinasabi ko na magkakaroon tayo dito ng number of section depende sa change in load na makikita mo doon sa iyo beam. So as you can see here, we have a concentrated load applied at 2 meter away from point A and another 28 kilonewton, which is acting 2 meter away from support D. And for number 2, draw the shear force and bending moment diagram. So sabi dito, neglect the weight of the beam. So yung self-weight niya, inineglect natin. So in other problems, there is a uniform load. So yung uniform load niya is because of the self-weight. So sometimes, kino-consider siya sa problem. But since dito sa problem na to, in-indicate na we will neglect the self-weight of the beam. So, i-analyze muna natin yung figure. So before that, we need to solve first for the reaction. So at point A, meron kang dalawang reaction, but yung horizontal reaction niya is equals to 0 since wala ka namang horizontal force acting at this beam. So pangalanan natin to as RA, and this one will be equals to RD. Okay? So upward siya since yung lahat ng load mo is directed downward. So pili ka na lang dito. So between A and D, moment ka para makuha mo yung isang reaction. So gagawin ko, magmo-moment na lang ako dito kay point A para ma-solve ko yung RD. So the equation for that, so assuming that all counterclockwise moment is positive, summation of moment at A equals to 0. So we have here, so 2, 3, 2, so that is 7 RD. So equals to 14 multiplied by 2, and then plus 28, and then multiply by 5. So we will have an answer for RD, which is equals to, so pinili naman sa LQ. Nasabayan nyo off. 14. So 14 times 2 plus 28 times 5 divided by 7. So the answer for RD is 24 kilonewton. And to solve for RA, mag-summation na lang tayo ng forces ng Y, or vertical. So summation of forces Y equals to 0. So RA is just the difference of 14 plus 28 and then minus yung RD mo, which is equals to 24. So with that, we will have a value for RA, which is equivalent to 14 plus 28 minus the answer. So that is equals to 18 kilonewton. Ayan. So ang RA mo dito, that is equals to 18 kilonewton. And for RD, that is equivalent to 24 kilonewton. Okay, so before we proceed, i-project ko lang ito. Kasi sa ilalim ng beam, usually mas maganda guys if dito mo i-drawing yung shear and moment diagram mo. Kasi nga, yung bawat diagram na yan is naka-base dun sa preceding o yung sinundan niya na diagram. So, ang susunod dito sa beam is the shear diagram. And then after the shear diagram, dun mo i-drawing si moment diagram. Okay, so this is for the shear diagram. So, again, i-denote natin siya ng V, or the unit of this is in kilonewton. And for the moment, so ang unit natin ng moment, so that is in kilonewton meter. So ito naman is not limited lang dito since ito is in SI. So ito yung unit na gagamitin natin. Okay, so let's analyze the figure. So dito nagkaroon ka ng tatlong change in load. So magkaaroon tayo ng tatlong section. So una, magsa-section tayo dito. Okay? So this section is good for the distance of 0 hanggang sa distance 2. Okay, next, at the distance 2, as you can see here, merong a 14 kilonewton na concentrated load. So mangyayari, dito magkaaroon tayo ng another section. Okay, so I will name this as my section 2. And last, will be at point C, nagkaroon ka ng 28 kilonewton. So magkaaroon ka ulit ng change in load. So magkaaroon ulit tayo dito ng another section. Okay? So, unahin natin i-drawing yung, isolate itong drawing na to. Itong section 1. So, considering section 1, ano ba yung makikita mo sa figure mo? So, again, it's either yung left portion or yung right portion yung i-consider mo. It's either ito, itong side na to, and ito. And magmamatter dyan yung table na pinakita natin doon sa introduction. Okay? So, unahin natin itong section 1. So, gawin ko na lang siya free body diagram, ha? So, dito sa point A, meron kang reaction A, which has a value of 18 kilo Newton. So, itong distance na to, ayan. So, I will let this as my distance x. Okay? So, yung equation na mapoproduce natin dito is good for the distance of 0 hanggang sa distance na 2. Ayan. So, hanggang dito siya. Okay? Now, so ano nga ang mangyayari? Alin nga yung positive shear kapag yung left side yung in-consider natin? So, yung shear na positive is pababa and yung moment natin is yung counter clockwise. Vice versa lang kapag yung right portion yung kinonsider mo. So, kapag right portion, itong moment na to yung positive and yung pataas yung magiging positive. Okay? So, ang gawin ko na lang, since yung nakasanayan naman lagi, is yung kaliwa yung i-consider mo. Okay, so let's make the equation for this. So, ang una, yung summation of forces ng y. So, assuming downward direction is positive, take summation of forces ng y equals to 0. So, we will have V, o yung shear mo, and then minus 18 equals to 0. So, ang gawin ko, i-transpose ko na lang sa kabila. So, that will be, ayan, 18 kilo Newton. So, the value of shear. So, this value of shear is applicable for distance of 0 hanggang sa distance na 2. Next, ano naman yung susunod? So, ang sunod na equation will be coming from the summation of moment. Ayan. So, assuming counterclockwise moment as positive, ayan, equals to 0. So, we will have here, so nung moment ka, meron ka dito moment M, and then minus, since ito is pa-clockwise, so minus 18 multiplied by the distance of x. So, ang gawin ko, di ba, equals to 0, i-transpose ko na lang ulit sa kabila. Ayan. So, ito yung working equation natin for the distance na 0 hanggang sa distance na 2. Okay, maliwanag? So, next, this time, we will now consider yung section 2 mo. Okay? So, para sa section 2, itong section 2 lang yung consider mo. So, ang makikita mo sa diagram mo ay itong mga sumusunod. So, una, meron ka dito na RA, which is equals to 18 kN, again. And then, somewhere here, meron ka na 14 kN. Okay? Again, this distance away from the sa point na nagkaroon ka ng section, I will let that as my distance x. And this distance, so this is equivalent to 2 meter. Okay? So, kailanganin natin yan kapag sa moment. Okay, now, so ganun lang ulit. The shear here, if left side yung i-consider mo, the positive shear is downward and the positive moment is counterclockwise. Okay? So this equation is applicable for the distance na 2 hanggang sa distance na 5. Okay? So this equation is applicable for the distance of 2 hanggang sa distance na 5. Okay, so unahin ulit natin yung summation of forces ng y. Again, downward is positive. Take summation of forces ng y equals to 0. So, what will be our equation? So, we have here the value of the shear. Ayan. So, idiretso ko na, equals ko, then 18, and then minus 14. So, the value of that shear is equals to 4 kN. So, ibig sabihin at a distance of 2, magbabago yung shear mo. So, distance 2 hanggang 5, ang value ng shear mo is 4 kN. Next, establish naman natin yung equation mo for moment. So, para kay moment, ganun lang din, kagaya na ginawa natin doon sa section 1. So, again, assuming that all counterclockwise moment is positive, take summation of moment at 0. So, our equation will be m, so equals ko na lang ulit. So, that will be 18x, and then minus since ito is magproproduce din ng counterclockwise direction and nilipat ko siya doon sa kabilang side, kaya naging minus 14 times, so x, so kailangan kong distance is ito. Okay? So that distance is equals lang sa x minus 2. Ayan. So x minus 2. Okay? And the last will be coming from this section 3. So ganun lang din. So when we consider the section 3, so ano yung makikita mo sa diagram mo? Ayan. So again, you have here the 18 kilonewton. And then here, we have 14 kilonewton. And somewhere here, meron ka na 28 kilonewton. So given yung mga distances niya, again, ito ang distance na to, coming from the left support hanggang doon sa section na pinutol mo. That is always distance x. Lagi And then ito, this is 2. And then yung gitna nila, so this is 3. Okay? So this equation is applicable for the distance of 5 hanggang sa distance na 7. Okay? So again, ganitong equation lang din yung gagawin natin. So take summation of forces ng y, assuming downward direction is positive. So we have here the force V is equals to 18 minus 14 and then minus 28. So what will be the answer here? So the answer there is 18 minus 14 minus 28. So that is negative 24. Okay? And for the moment, so assuming counterclockwise moment as positive equals to 0, so the equation will be moment m is equals, so again, that is 18x. So ang mangyayari lang dyan, guys, parang koopehan mo lang ulit yung sinundan mo. So diretso na natin 14 times x minus 2. And then minus 28 of x minus 5. Alright, so meron na tayong mga equation. So I think we can now draw the shear and moment diagram. So ganito lang yung gagawin mo dyan kapag magdodrawing ka na shear and moment diagram. Okay, so let's start first drawing the shear diagram. So guys, you will always start here at 0. So dito ang magsisimula at point A. So dito is 0 pa yan. And then ang sabi sa kanya, so ano bang kulay ang gusto nyo gawin natin? Sige, pula na lang ulit. So ang sabi, sa shear mo daw is magiging 18 kilonewton. So positive value siya. So ibig sabihin, tataas ka dito ng 18. Okay? So coming from 0. And then this equation is applicable for 0 to 2. So lahat ng value ng shear is positive 18. So ibig sabihin, ano ba yung distance to po? Di ba hanggang dito yung distance to? Ayan. So 18 yan hanggang dito. Okay? So next, yung distance na 2 hanggang 5. So since may concentrated load ka dito, tandaan nyo guys na kapag concentrated load yan, meron kang dalawang value ng shear dyan sa point 2 or at distance 2. Okay? So ang sabi dyan, at a distance 2 hanggang 5, yung value niya is magiging 4 kilonewton. So coming from 18, bababa ka lang dito kasi ito is distance 2 pa din. Ayan. So this is 4 kilonewton. And then hanggang distance 5 daw siya. So ibig sabihin, so hanggang saan ba ang 5? Diba hanggang dito? Ayan. So diretso mo lang yan. Alright. So that is 4 kilonewton. And then next, for the distance of 5 hanggang 7, so again, 5, as you can see here, at the distance of 5, meron ka ulit concentrated load. So magkakaroon ka ulit ng dalawang value for the shear at this point. So meron kang tinatawag na shear left and shear right kapag may concentrated load. So coming from 4, meron ka daw ulit some value which is negative 24. So kapag negative, nasa baba lang ng plane na ito. So magiging negative 24. So negative 24 kilonewton. And then this negative 24 kilonewton is good hanggang sa distance na 7. So dire-diretso ka lang. Ayan. So this is negative 24 kilonewton. Okay. So guys, as a checking, from the original diagram, dapat kasi kapag support yan, babalik ulit siya dun sa 0. So ito, nagsimula siya sa 0. So ito, dapat matatapos ka lang din ulit sa 0. So sabi dito sa point D, ayan, meron kang reaction which is 24 kilonewton na pataas. So negative 24 plus 24, so that will be equals to 0. Okay? Ayan. So guys, I don't know if na-share ko sa inyo, di ba? Doon sa topic yata na centroid yun or doon sa moment of inertia. Alam natin na yung mga line mo is a negative 1 degree curve. Kaya, so sabi ko nga sa inyo, di ba, magiging plus 1 ng plus 1 lang yung degree ng curve sa bawat susunod na diagram. So kung ito ay negative 1, so ito magiging 0 degree curve. Or kapag 0 degree, that is in rectangular shape. So straight lang siya. Okay, next. So sunod na diagram mo. So if this is 0 degree, so mangyayari first degree curve siya. Ano ba yung first degree curve natin? Di ba in the shape of a triangle? Or pwede rin sa natin sabihin ng trapezoid. Okay? So, one key note natin for drawing the moment diagram is that, sabihin natin ang degree. So, kapag guys, nasa support ka, lagi niyong tatandaan, take note of this, na 0 moment ka kapag nasa support. Ibig sabihin, since ito is simply supported sa bawat dulo, dapat silang dalawa dito ay magtatapos or magsisimula sa 0. Okay. So, simulan ulit natin dito. So, sabi dyan, ito nga, yung equation mo for moment for the distance of 0 hanggang 2 is 18x. So, itong x na to, papalitan mo lang ng mga value yan. Depende sa distance na gusto mong malaman yung value ng moment. Okay? So, at a distance of 0, so ito, 18 times 0, so that is equals to 0. Which is correct. Kasi nga, sabi ko sa inyo, kapag support, 0 moment yan. Okay, next. So, ito, pwede mong palitan ng 1. Pero, for example, i-require sa'yo sa problem, what is the moment at a distance 1 meter away from the beam? So, isasaksak mo lang yun dito yung value. But tandaan nyo, again, itong equation na to is good lang for the distance of 0 hanggang 2. So, kapag pinahanap sa inyo yung moment at a distance of 3, so ito ba yung gagamitin nyo? Siyempre, hindi. Itong kapartner niya or itong section kung saan yung distance x mo is from the distance of 2 hanggang sa distance ng 5. So, dito mo ilalagay yung value ng 3. Hindi dito ha, hindi dito. Okay? So, clear tayo dun ha. Again, always take note of the limit para malaman mo kung saan lang siya pwede gamitin yung equation na yan. Okay? So, palitan natin ito ng 1. At a distance of 1, that is 18 kilonewton meter. Okay? So, first degree lang siya. So, ano lang natin. So, at dito sa gitna nito, ang value daw nito is 18 kilonewton meter. Pero ang gawin nyo na lang, doon lang tayo sa may mga doon sa may mga broken line, or itong mga broken line, nilagay ko lang siya doon sa mga point kung saan nagkaroon ka ng change in load. Okay? But anyway, again, gaya nga nasabi ko kanina, if ipahanap sa inyo yung moment sa distance ng 1, pwede nyo gamitin or pwede nyo mahanap using this equation. Okay? So, gawin ko na lang, ito, palitan ko. So, 18 times 2, so that will be equals to 36. So, ang value ng moment mo dito is 36 kilonewton meter. Okay? Next, let's now proceed with the next section. So this time, etong equation na to yung gagamitin natin. Okay? So i-check lang natin. So again, this is applicable for the distance of 2 hanggang 5. So i-check natin kung pareho lang din pa siya nalalabas kung distance 2 siya. So tinuruan ko sa iyo sa ALQ nung yung technique. So input nyo lang to sa ALQ, 18, and then x, lagay nyo yung x, minus 14, and then the quantity of x, minus 2. So, kung ano yung nakita nyo dito sa equation na to, ito rin yung isaksak nyo sa ALQ. So, ang pindutin nyo lang is calc, yung calc na symbol, yung katabi ng option. So, pag pindot nyo ng calc, so, maghahanap sa inyo ng value ng x. So, unahin natin ilagay yung value ng 2. Check natin kung magbabago siya. So, sabi, 36 pa rin siya. So, walang mangyayaring pagbabago dito. 36 pa rin siya. Next, ang gawin natin, so again, pwede mong ilagay dito, pwede mong i-input 3, 4, 5. Actually guys, ito pwede rin may mga point. Pwedeng 2.5, 3.2, or depende na lang sa problem kung may specific point na pahanapan sa inyo ng value ng moment niya. Pero since dito lang nagkaroon ulit ng change in load sa distance ng 5, so input ko na lang dito is yung 5. Okay? So calc ulit natin. So lagay mo yung 5. So ano lalabas na sagot? So that is 48. Okay? So, ibig sabihin dito, so ibaba ko lang pala ng kaunti kasi baka sumapaw dito sa kabilang diagram. Ano? Para lang ano yung diagram natin. Okay? So, palitan ko na lang siya ng kulay na blue. Para lang din na. So, ano nga dito? So, coming from 0, magiging 36 siya. Ayan. So, 36. Kahit hindi ko na pala isulat yung unit guys, so, para hindi sikip. Kasi nilagay ko naman dito, sabi dyan, kilonewton meter siya. So, ilagay ko na lang dito is 36. Okay? So, and then, at a distance of 5, magiging 48 siya. So, ibig sabihin, tataas pa siya dito. So, again, dapat triangular yung shape lang yan or straight siya. Ito lang natin. So, ang value niya dito, this is 48. Ayan, 48. And then next, we will now apply the equation for the limits of 5 hanggang sa 7. Or itong equation na to. Ayan. So, again, isaksak mo lang yan sa calcu. So, from the previous equation, dagdagan mo lang siya ng minus 28 with the quantity of x minus 5. So, calculate natin. So, ayan. So, check lang muna ulit natin at a distance of 5. So, nasabi dyan, 48 pa rin siya. Okay, so ganun pa rin siya. And then last, so dito na ulit tayo nagkaroon ng change in load dito sa point D or kung saan nandun yung support. So, i-calculate natin. So, this time, ang input nating answer is, ang value ng x is 7. Ayan, so 0 siya dito. Okay, which is correct kasi nga, sabi ko sa inyo, doon sa mga support mo, dapat magsi-0 siya. Ayan. Yun, so 0. Right, so ito yung shear and moment diagram natin. So guys, ito lang yung kailangan yung bantayan dito. Ito yung mga isa pa sa mga key pointer natin. So, i-analyze nyo or inspect nyo yung ating shear diagram. So, saan tayo nagkaroon ng zero shear dyan? Aside from dun sa mga support mo. Saan nagkaroon ng zero shear? Diba dito? Ayan, dito sa point na 5 meters. Okay. So, tandaan nyo guys na kapag nasaan yung zero shear, nandun rin yung location ng maximum moment. Ayan, no? So, ito yung maximum value ng moment natin. Okay? So, usually guys, doon sa susunod na chapter natin, ang kinukuha dito are yung mga maximum value. Okay? So, usually, yung shear max and maximum moment yung kinukuha dyan. So, sa moment, mayroon siyang, depende rin sa problem, pwede mo siyang i-design using the maximum positive moment and pwede rin yung maximum negative moment. So, depende na sa problem yun. Ano? Pero, ganito lang yung basic approach. Ano? So, again, tandaan, kapag nasaan yung zero shear, andun yung maximum moment. Ayan. So, kung makikita mo dito sa diagram. Okay. So, let's try another example.